For about 100 years, quantum mechanics has been, without a doubt, the most successful theory in all of science. It's the engine behind your phone, medical imaging, pretty much everything. But here's the thing, it's been holding on to this deep, unsettling secret. We've become absolute masters of how it works, but we have almost no idea why it works the way it does. Today, we're going to explore a pretty radical new idea that might, just might, finally give us the answer we've been looking for. And yeah, that's really the heart of the matter, isn't it? Physicists have the rulebook down cold. I mean, the math is perfect. But if you try to pin one down and ask, okay, but why does the universe have to be so fundamentally weird? You're probably going to get a shrug. Why all the probability? Why this deep, strange layer of reality? That's the puzzle we're trying to solve. All right, so before we can even touch the solution, we've got to really wrap our heads around the problem. So let's do a quick flyby of the bizarre set of rules we've uncovered over the last century. Think of these as the clues in our cosmic whodunit. So, you've got superposition, right? This idea that a particle can be in many places or states all at once. Then there's entanglement, what Einstein famously called spooky action at a distance. We've got quantum tunneling, where particles just kind of pop through solid walls they shouldn't be able to. This constant confusing flip-flopping between being a wave and being a particle. And, of course, the big one, the measurement problem, where the simple act of looking at something fundamentally changes the outcome. These are the mechanics we know and, well, we know them. And this slide just nails it. This is the whole thing in a nutshell. It's like we've stumbled upon this incredibly complex, mysterious machine. We found all the gears, we know which levers to pull to make it work, but we have absolutely no clue what it's building or why it even exists. We get the how, but the why, the purpose, is a total blank. Okay, but what if we've been looking at this whole thing completely backwards? What if the universe isn't a collection of things at all? What if it's a process? What if it's a computation? This right here, this is the shift in perspective. The idea is that the universe isn't just some passive stage where particles are doing their weird quantum dance. No, the universe itself is an active information processing system. It's constantly running a program, an algorithm, to figure out the most stable, most efficient states of existence possible. And the name for this cosmic program is coherence optimization. Now, just to be super clear, we're diving into some fascinating cutting-edge thinking here. It's not exactly textbook physics yet, but the core idea is that this universal algorithm is always trying to maximize stability and how interconnected everything is. And all those weird quantum effects we talked about, they aren't bugs in the system, they're features. They're the very tools the universe uses to compute reality. And get this whole new way of looking at things actually comes with its own master equation, a single line of what you might call reality's source code. Now, I know it looks simple, but this little formula supposedly governs the entire cosmic process. So come on, let's break down what these letters actually mean. All right, let's crack this thing open. I stands for organization, basically how complex or structured something is. Think about the difference between a random cloud of gas and a perfectly formed star. That's I. Then C is for coherence, how connected and in sync something is with everything around it. And finally, E is energy. You can think of this as the cost, the price of maintaining that specific state. The whole theory proposes that the universe is in this constant dance, trying to find the perfect balance between these three things. Okay, so we've got this new theory, this new lens to look through. The big question is, does it actually work? Let's take this idea of a computational universe and throw it at some of those classic quantum puzzles and see if they suddenly start to make a little more sense. Let's start with entanglement. The old view is this spooky action where two particles seem to be sending signals to each other faster than light. The new view? Forget communication. There is no signal. The particles are just two parts of a single shared computational state. When you measure one of them, you're not sending a message to the other one, you're just resolving the calculation for the entire system all at once. Okay, what about wave-particle duality? This isn't a particle having some kind of identity crisis, not knowing what it wants to be. It's just two different phases of the same process. The wave part, that's the universe exploring all the possibilities. That's the calculation happening. And the particle part, that's the final answer, the output of that calculation. It's not one or the other. It's a sequence. First the calculation, then the result. And that little idea, that calculation phase, well, that's where things get really, really weird. This leads us to probably the most profound insight of this entire idea. It completely flips our understanding of time on its head. Here it is. This is the big one. When a particle goes into superposition, When it's in that wave or calculation phase, it effectively steps outside of the normal flow of time as we know it. You might be asking, how is that even possible? Well, just think about what's actually happening in superposition. The particle doesn't have a specific location, right? It doesn't have a defined structure. So its organization, that I value from our equation, is basically undefined. It's not a concrete thing in a specific place. It's just this cloud of potential. And now, look what happens when we plug that back into our equation. If the I value, the organization, is basically 0 or undefined, then t, which represents the temporal state or time, also drops to 0. The math tells us the particle enters a timeless state. It's no longer bound by the normal rules of cause and effect that run our world. So what this framework is really telling us is that reality operates in two fundamental modes. You've got the calculation mode, this timeless, wave-like superposition state where all possibilities are being explored at once. And then you have the output mode, the particle state we actually experience, where one of those possibilities becomes real and gets locked into our familiar timeline. And this two-mode model, it isn't just a cool thought experiment. It might just be the most beautiful, elegant explanation we've ever had for the single most famous and most baffling experiment in all of physics, the double-slit experiment. Just picture it. The electron is fired from the gun. It immediately enters its timeless t=0 state. It's not a little bullet flying through space anymore. It's a pure calculation, exploring every single possible path through both slits at the exact same time. It's not in a rush. It has no time. It's computing the most coherent, stable pathways, and that computation is what we see as the interference pattern on the screen. The pattern is literally a map of the timeless calculation. Okay, let's step back for a second. What does all of this mean? If this way of thinking is even remotely on the right track, it represents a massive fundamental shift in how we see, well, everything. At the end of the day, it means the universe isn't made of tiny billiard balls that follow a set of bizarre, magical rules. Instead, the universe is a gigantic computational engine, and its prime directive is to optimize for coherence. And quantum mechanics? It's not a set of strange rules. It's the source code. It's the operating system for reality itself. This is the paradigm shift, right here on one slide. We go from this confusing, frankly baffling universe where particles do magic tricks we can't explain, to a surprisingly elegant one where the universe is simply running an algorithm. The particles themselves aren't even the main show. They're just the output of a much deeper, more fundamental computational process. And that leaves us with one final, absolutely mind-bending question to chew on. We live out here in the output, this world of solid objects and time that only moves forward. But if our entire existence is just the end result of some vast, timeless calculation, what's it like inside the computer? What's happening in that timeless realm where every single possibility is real all at once? Now that is something to think about.